Namaskar, Adab, Shat Sri Akal. Welcome to our channel and welcome to the discussion of group theory. Yes, this is the live class number 9. Okay, and I would like to say what the things are going to be discussed in this lecture, in this class. In this class, we are going to discuss about, yes, I mean to say if a group is given and its order is either prime or product of prime or power of prime, then how can we say this particular group is isomorphic to just one group or more than one group? And there is what are the possibilities for Z to be isomorphic to different kinds of group? Okay, so certainly we are going to discuss all these things in a proper way. So let's go to start this session in a proper way. I would like to say, first of all, I will discuss the fundamentals, okay, and thereafter some previous year questions. Certainly MCQs and MSQs will be there for sure. So first of all, I would like to say, if you have a group of order P, if you have a group of order P where P is prime, then there exists just one possibility. Okay, then we have unique possibility. Okay, we have the unique possibility that our Z is isomorphic to ZP. Okay, then certainly we will have the unique possibility that our Z will be isomorphic to what? ZP. And if what is the second case? If we have the order of the group G is equals to P square. Internet is not working. Internet काम नहीं कर रहा है क्या? पता नहीं क्या प्रॉब्लम है. काम नहीं कर रहा ना? कर रहा है. अभी हम लाइव हैं. Yes, we are live now. Okay, so if order of Z is equals to P square, then there exist two possibilities. In this case, how many possibilities are there? Certainly two possibilities. What are the possibilities? Is certainly our Z will be either isomorphic to ZP square, or it will be isomorphic to ZP cross ZP. Okay, certainly we are going to discuss some examples for sure, and CSIR used to ask the question on this. Okay, for example, if you have a group of order 121, okay, then certainly this 121 can be written as the power of prime 11 ka square, and this G will be isomorphic to what? Either it will be isomorphic to Z 121, or it will be isomorphic to what? Certainly ZP cross ZP means what? Z11 cross Z11. So in this case, if the order of Z is P square, I mean to say square of a prime number, then there are two possibilities for this G, that either this G is isomorphic to ZP square, or it is isomorphic to ZP cross ZP. So on this property, certainly we have a very beautiful example over here. Now I would like to ask, I would like to discuss another very good result. So yes, the third result says what? Because certainly you will see some previous year questions on it. If order of Z is equals to product of prime, I mean to say it is P into Q, where P is strictly less than Q and P is not going to divide this Q minus 1, then there exists a unique possibility. Then there exist unique possibilities. And what is that? Then there exists unique possibility. And what is that? Certainly your G is isomorphic to Z PQ. Okay, in this case also you will have unique possibility. I would like to give you some examples on it. For example, if you have a group of order 15, then certainly this 15 can be written as 3 into 5, isn't it? And here what was the result? If your order of G is equals to P into Q, where P is strictly less than Q. So here you can see this 3 is strictly less than 5. And also what were the thing? That this P is not going to divide Q minus 1. So what is your Q minus 1? 4. And this 3 is not going to divide this Q minus 1. Okay, so yes, for the group of order 15, we can see easily that how many possibility will be there? Just unique possibility, because all these conditions are well satisfied, and therefore your G will be isomorphic to Z15. Okay, so yes, these are the results, and very nice result we can say. So before coming to the question, we should discuss the things like, if you have a group of order 4, then certainly then this can be written as 2 raised to the power 2, and 2 raised to the power 2, I mean to say it is of the form P square. So certainly your Z will have two possibilities. Either your Z will be isomorphic to Z4, or your Z will be isomorphic to Z2 cross Z2. So two possibilities will be there. Let's do a few more quick questions. If you are given the group of order 9, then certainly the group of order P square. So once again we will have how many possibilities? Certainly two possibilities. Either it will be isomorphic to Z9, or it will be isomorphic to Z3 cross Z3. Okay, so this is how we used to see and say the things. I would like to give you another example. If you have a group of order of 49, then once again it is of order 7 square. So either it will be isomorphic to Z49, or it will be isomorphic to Z7 cross Z7. All right, so this is how we are going to decide the things. Okay, and sometimes this kind of questions I would like to say certainly comes. Okay, and we'll discuss a few questions on it that has been asked in CSIR net. But before coming to that, we would like to discuss some more cases. Okay, the next result is what? If it is given the order of the group Z is equals to P into Q, where P is strictly less than Q, and this P divides Q minus 1, then there exist two possibilities. Okay, remember, when this P were not dividing this Q minus 1, then in that case unique possibility was there, isn't it? Before this you had seen this result. But if this P is going to divide this Q minus 1, then there are two possibilities. And what are those? We can see it easily. Certainly your Z will be either isomorphic to a group ZPQ, or your Z will be isomorphic to a non-abelian group. Okay, and on this result, CSIR net question we are asked. So certainly we can find a non-abelian group, and certainly the dihedral group we can say, or different kinds of non-abelian group may be there of the order P into Q. Okay, and one of them I am just going to write. We can construct the non-abelian group in the form of this: x raised to the power P is equals to E, and y raised to the power q is equals to e, and certainly as it is non-abelian, that's why xy is not equals to yx, and don't forget that your I goes from 0 to p minus 1 and your j goes from 0 to q minus 1. Yes, these are the things for non-abelian group. Now I want to ask and I would like to ask a question on it. Okay, for example, if I would like to say that the order of the group Z is 10, so certainly it can be written as 2 into 5, and we can observe that this 2 is going to divide this 5 minus 1. Then how many possibilities will be there? Certainly 2 possibilities. Okay, either it will be isomorphic to Z10 or it will be isomorphic to some non-abelian group. So let's say D5. So there are 2 possibilities for this, as it satisfies the condition that the order of the group is the product of prime and one prime is going to divide another prime minus 1. Okay, so that's why these conditions were satisfied, and therefore this G will be either isomorphic to Z10 or it will be isomorphic to D5, because both have the order 10 for sure. One is cyclic, another is non-cyclic, okay, even non-abelian as well. So certainly these are very interesting things, and this kind of things is going to be asked by CSIR net. So I would also like to discuss that once upon a time in CSIR net which kind of questions were asked. But before that, if you have the order of group 21, then certainly in this case it can be written as 3 into 7, and you can observe that this 3 is going to divide this 7 minus 1 beautifully, and therefore you will not hesitate to say that your group Z is either isomorphic to Z21 or it is isomorphic to some non-abelian group of order 21, non-abelian group. Okay, so yes, these were the things. Now let's come to a question that has been asked by CSIR. Okay, in that question order of Z were 122, and then they have asked that how many what are the possibilities for this G. So in this case we can easily observe that as the order of group Z is what, 122, and it can be written as the product of 2 primes, 2 into 61, and we can also observe that this 2 is going to divide the 61 minus 1. So yes, it's true. So certainly according to the previous result it will have how many possibilities? Certainly 2 possibilities, and in one possibility where this G will be isomorphic to Z122, and another possibility is what? Certainly a non-abelian group, which is what? D61. Okay, so yes, this has been asked in CSIR net. I have just shared you the information, not the exact question, but now it's the time to discuss a question that has been asked in 4.75 type. Okay, question. So let me write that question. The question was given as, if order of Z is equals to 14 and Z has no elements, of order greater than 7, then how many elements of order 2? Then how many elements of order 2? Okay, then how many elements of order 2? Order 2. And also some properties related to these questions were also given. So in the first option it was given that Z has exactly 7 elements of order 2. Z has exactly 7 elements of order 2. Okay, And in the second option, option B, what are the things were given? G has exactly one element. G has exactly one element of order 2. What about the third option? G is non-abelian group. G is non-abelian group. Okay, and what about the last option? G is abelian but non-cyclic. G is abelian but non-cyclic. Okay, so yes, these were the things. So first of all, every conclusion depends on the order of the group, isn't it? And certainly those 4 properties. So we can say what? Order of Z were what? 14. And it can be written as the product of primes in terms of 2 into 7. And we can also observe that this 2 is going to divide this 7 minus 1. Then how many possibilities will be there according to that result? You will not hesitate to say there will be 2 possibilities. Either this G is isomorphic to Z14 or this G is isomorphic to D7. So what are the conclusions? Don't forget that one condition were given, that G has no elements of order greater than 7. Yes, these were the condition. And certainly this condition will decide whether this G is isomorphic to Z14 or isomorphic to D7. That condition matters. Okay. So if we are going to take, if your Z is isomorphic to Z14, then Z14 has elements of order 14 also, isn't it? It's a cyclic group. So it has elements of order, it has elements of order 14 also. Okay, but in the question it was given that it has no elements of order greater than 7. So that's why what shall we say? We shall say that this G is not isomorphic to Z14, because in the question the condition was given that G has no elements of order greater than 7, but this Z14 contains the element of order 14 being cyclic. Therefore this G is not isomorphic to Z14, and therefore your G is isomorphic to D7. And you know here D7 is the thing, 7 is odd, and as it is odd, therefore what shall you say? 7 elements of order 2 will be there. Okay, because in order wala class we have already discussed, if n is odd, then how many number of elements of order 2 will be there. If n is even, then how many elements of order 2 will be there. So as D7, so 7 is odd, so exactly 7 number of elements will be there whose order will be 2. So we will not hesitate to say that option A is absolutely right. Second is what? G has exactly one element of order 2. Certainly not true. G is non-abelian group, obviously, because dihedral group is here. Okay, and D7 is there, so certainly non-abelian. And Z is abelian but not cyclic is not true. So your final answer for this question is what? A and C. So this was a 4.75 type question that were asked in CSIR net. So now I'm just going to give you a homework problem that has been also asked in CSIR net, and tomorrow we will come up with the solution of that question. So what is the question right there? If order of Z is equals to 55 and G has elements, and Z has, in the previous question it was given that G has no elements of order greater than 7, but in this question Z has element of order greater than 11. Then what would you like to say? In option A it is given G is non-abelian. G is non-abelian. In option B, what the thing is there? G is abelian but need not be cyclic. G is abelian but need not B. Cyclic. Okay. Option C, G is always cyclic. And option D is what? None. So it's a CSIR net question, and certainly you must remember that this 55 can be written as the product of two primes, and four results were there to help you, and you cannot forget, because certainly it will be isomorphic to more than one groups if possible. And if it is so, then you must consider this condition to get the exact group which is isomorphic to Z, and once you will find the group which is isomorphic to Z, a well-known group, then that well-known group will help you to say the right answer of this question. So certainly I think we will start this session. We will continue this session tomorrow onwards, and certainly the first question of tomorrow's night will be what? This one only. Okay, so please try. We'll see you tomorrow. If you are watching it recorded, then certainly you can come live at 8:30 p.m. daily. Okay, so we'll see you tomorrow. Till then, take care. Bye bye. Jai Hind, Jai Bharat, Vande Mataram.